I would like to, hello, I'm Daria Frolova, and I'd like to introduce our protein language model novel. Currently, a lot of structural information along with information about protein sequences is available because of the AlphaFold. The structural information is mostly processed by graph approaches, which have some drawbacks like the need for equivariance and so on. So our idea is to add some structural information about protein into the successful language models, into transformer models. There are some approaches that do this already. For example, people translate from sequences to structural alphabet and use contrastive learning to add structural information to protein representations. So we propose another approach, a structural protein language model, Structplm, where we add some structural information along with letters into the same sequence of protein. It is known that amino acid side chains can exist only in few possible positions or rotamers, so they can be easily tokenized into types or categories. Also, the structure of a protein is described by backbone torsion angles phi and psi, so we binarize them and use also as tokens. Finally, we train our language model with slightly modified cross-entropy loss in order to perform angle regression. So it's better to be mistaken by 1 degree than by 50 degrees. We trained our model on the structures generated by AlphaFold, and then fine-tuned it on experimental structures. We train a small model, which is much smaller than, for example, ESM or protein T5. And we evaluate protein representations that we obtain on the prediction of protein stability change due to single mutations. This is a per residual prediction, and we follow the setup used in the top performing method Abyssal. We use the same data sets and so on. So we replace ESM embeddings that were used in Abyssal with our Structplm ones. Also, we test the concatenation of ESM embeddings and Structplm. In our results, our small model performs worse than ESM. However, if we compare it with ESM model of similar size, we see that it is comparable or slightly better. But if we concatenate ESM with our embeddings, the yellow bars are always better. So we think that structural information can enhance protein representations. That's all. Thank you. So I'm ready to answer your questions.
Thank you for your presentation. And there is some questions from Pavel Pagodin. Daria, what do you model predict?
Our model is trained on masked language modeling objective, like all language models. And then
I don't hear you very well.
Representations of proteins on downstream tasks. So
you don't hear you very well.
Please speak loudly.
Dr. Sivanandam asked a question. Do you use Ramachandran plot to validate your model?
Yes, we did. We did, but didn't show it here.
Okay. Is there any other questions? How can you estimate DDG values based solely on the protein geometry from Dr. Yefremov?
It's not only a protein geometry, it's also amino acid letters. They're also used. So the small neural network is trained upon these representations.
What about the force field used?
No, we didn't do it
You
on
didn't.
the language models.
Dr. Faletrov asked. No, it's not you. There is no other questions from what I see.
May I ask one question? If you do not use force field or quantum chemistry, how can you calculate change in the binding energy?
That's exactly what I'm
energy.
typing.
Currently, top performing approaches in this task also don't use force fields, only ESM embeddings. So language model can capture some information, I guess.
But the
Where
question is
the energy?
how you calculate the
I don't-
energy.
No, just regression language neural networks that performs regression and outputs one number, energy.
So the energy is hidden somewhere in the neural network.
Yes, sure.
It should
Abyssal
be
approach.
somewhere.
It's
Because-
we follow the step of abyssal, a neural network here. We just replace input data for this method from ESM to Structplm ones.
So it's just a black box for you, right?
Just feed forward neural network for regression.
I see. It can be dangerous if you don't really know from where the energy values come, the force field parameters and so forth.
Like with all machine learning, I think.
Yeah, this is the question. Okay, thank you.
There is no other question?
Thank you.
Okay. Thank you very much.